Another example of creating this. Okay, so I'll bring this back and just correct this first, and there we have our input values. Now we have created our lot plan using the line command and separated this individually. So we can do this better using a more improved line command, which is the polyline. Okay, so type PL for polyline. So enter. So let's redo our title block. This time, just near. Okay, no need to start from the origin. For as long as it's near the origin. So let's click anywhere near the origin, but not too near the initial lot plan that we created. So let's say start here, and then let's start all over again. So at 7,890. For the angle, you notice here that it is already being shown by the dynamic input that you could enter next the angle. So instead of looking and typing or hitting the angle bracket key on your keyboards, you can just hit the tab key. So I'll click on the tab, and there I'm already at the angle. Okay, so I'll just type the angle now. South 28 degrees 50 minutes east. Enter. And then another one at 5,970. For the angle again, just press tab, and then south 61 degrees 10 minutes to the west. Enter. And then next again, 4,000, then tab, south 87 degrees 15 minutes west, then enter. And then at 13,730, and then tab, north 66 degrees 41 minutes going west, then enter. And then at 4,000, tab, and then north 15 degrees 16 minutes west, enter. And finally 11,800, angle or tab. Okay, and then N 36 degrees 8 minutes east, enter. So this time we could look at the options for the polyline. You could create an arc instead of locating the next point, or you could close it, or you could improve the width of the polyline, or improve the length, or undo, or provide a width for your polylines. But this time we want it to be closed. Okay, again we could undo. So type undo, for example, and then it undone the previous line. So let's redo it again. So at 11,800, tab, north 36 degrees 8 minutes east, enter. And then this time I want to close it, so I'll just type C for close, enter. Now once I hover my cursor over the lot plan created with the polyline, it could select all of the geometries already. So it's just a single entity. So let's go to the properties. So right click, properties, it's a polyline. But when we click on this initial created, escape first, and then click on this, it's just a line. Okay. However, to select them, you could select it through a window selection or crossing selection. This one, just simple crossing selection. Could easily be selected all of the geometries of the lot line. But we could also select this one, and then we just type J to join the geometries. Enter. And now when we go to properties, it's now a polyline. Okay, so either way you could do it in line or polyline, but for me polyline has, for example, PL, enter, and then you would notice there are much more options that you could create with polyline, and that will be our next topic for the succeeding modules. But for now, let's content ourselves with this exercise, creating lot line using relative polar coordinate value. By the way, I updated the data on our lot description. I already included line 7-1, which is 15 meters with a direction of south, 53 degrees 52 minutes east. Okay, so you could complete that onto your exercises. But if this bearing will not close, just close your geometries. Okay, the precision in surveying is around there's allowable error of 8 inches. Okay, for geodetic surveying. So if there is an error plotting these coordinates and bearing, I mean distance and bearing, then that's the fault of the geodetic engineer. So if it doesn't close, just instead of typing the coordinate for line 7 to 1, just close the geometry. Additionally, we could also perform some inquiry commands here. Let's say, for example, the distance. Okay, let's check the distance, for example, for line 7-1. So let's type di. Okay, so di for distance. So enter, then specify I want to measure from this point to this point. Okay, so I'll click here in this snap point, and then click in this snap point, and there's an error. Okay, so meaning there's already an error on the geodetic survey. As shown by AutoCAD, it's not exactly 15 meters. So a while ago we closed this one. We did not input these coordinates. Okay, so obviously when you use this coordinate and distance, I mean bearing and distance, this will not close. So better don't use this, just close your geometry for precision in AutoCAD. Okay, because I repeat, geodetic surveys are allowed with a margin of error of around 8 inches. Okay, so if you have boundary issues, blame that to the geodetic engineers. And that's, for example, line 6-7. This must be 11.8. So this is accurate. Okay, so this is from this point to, so this is point 7. Okay, so point 7 to point 6, it must be 11.8, and it's correct. I'll click, and as noted on our tooltip, distance is 11,800, and this must be true to the other lines. This, for example, the first line that we have created. So di again, enter. So from point 1 to point 2 must be 7.89, so 7,890. So it's correct. The only error here is the line 7-1. And additional inquiry that we could do here is the area command. Okay, so type area, so AREA, and then enter. You can either do this with the long cut. You could select every point, but since we created this as a polyline, you could just treat it as an object. Gladly, we have option for object under area command. So this is a single object because this is created through a polyline. But if this is a single connected lines, we cannot select object. We have to select from point to point to point to point until it's closed. But since we made this using polyline, we could treat it as an object. So select object or type O, since it's the capital letter on the options. So O, enter, and then select the object. So select the polyline, and there the area is around 246. And let's check the lot plan, and it's 246 square meters. So again, AutoCAD is really that precise. Let's check the history. F2. So 246. It also the perimeter, okay? The total length, perimeter of the lot. So that's area and distance commands.